Welcome back, all of you. There was a network problem in the campus, so we had an interruption in between the talk. So a new link has been shared to all the participants, so you can join through that link, and the talk will resume in a short while. Dr. Animesh, can you hear me?
Yes. Yes.
Sir, you can start your talk from the
Yeah.
part that you have left.
Yeah. Okay. So just to recap, I mean, sorry for interruptions in between. But what I was telling earlier is, um, regarding the data fusion. So data fusion in the sense that we have, we need after you identify the important features from multiple different data sets. This is the step. I mean, you want to combine, and what I'm saying in this figure is just using the simple correlation based analysis. You can find out different interesting cliques and interesting associations. Yeah, and those associations has been validated further for experimental settings. For example, those genes believed to be part of bile acid metabolism, which is very different from the ulcerative colitis or IBD sort of disease. So, and then if you wanted to read a little bit more on the methodological aspect, so this is the paper we published early this year, in Journal of Crohn and Colitis. But as I said, I mean, there are huge part has been gone into the data modeling and other aspects. But you can see the graph or many of the different skills I've been talking about is very transferable skills, and not necessarily they can be applied only on the clinical data. So he was my former PhD student, and he is now assistant professor in IIM Shillong in India, and he has been published many different papers in his PhD studies just based on the graph theory. But this is the data not on the clinical data, but in the non-clinical, like stock market, Asian equity market, and all these sort of. So what all I'm saying, this is the last part, and I'll take maybe 3 to 4 minutes just to explain. So it's very essential that we collaborate for multiple disciplines and form a team, and then try to solve the problem. So here in my definition is a definition of the interdisciplinary science is coming from multiple different aspects like engineering science, basic science, social science, clinical science, and then the idea is they interact with each other. Yeah. For me that I'm using quite a lot, borrowing concepts from multiple different domain and then applying to solve a clinical research type of. But nonetheless, there is ample opportunity for method development, applications, and more importantly, collaborating and finding a new way combining them. So I'm talking about the collaborations. In the collaborations, I've been involved in many different departments, like as I said, trauma, cancer, burn, and these are all clinical things. But nonetheless, they're kind of a highly or tightly associated with hospital versus different other departments. Also, across the globe. I've been working with other stakeholders with Harvard Medical School, University of Parma, Italy, Manitoba, Amsterdam Medical Center, University of Cambridge. I've been in Cambridge for 3.5 years working in Cambridge, but also now I go occasionally collaborating. But they are multiple different disease, and we not only so we make sure that we get some sort of output from this sort of collaborations and publish those results. So the key message what I want to give is that you have a big data. I started with the big data, and then I showed the different feature identification approaches, identify the marker, and those markers are useful for biomarker discovery. And definitely, it needs an interdisciplinary team, and collaboration really matters in these aspects. These are the teams. So so I'd like to thank other people in our group, like Laura, Vartika, John, and Joseph. They have been working a lot in this omics analytics domain, but also my other collaborators group. And I would finally like to thank the audience and who are including Dr. Ishamal and Professor Rajit in this aspect. And if you have any questions or anything, you can approach me. You can send me anytime email, and it would be it will be nice if you can collaborate in some of the common areas and where we can solve combinations. So I know NIT Silchar, they are very strong in the technical side, but we are very strong at technical, but also the experimental side as well. And thank you very much for the opportunity. Questions? Comments? Is there any questions?
So since there were some technical issues in between the talk, maybe some participants have skipped the question now. So at this point of time, we are not having any questions right now from the participants.
Yeah, no, that is understandable. That's fine. But yeah,
but we are waiting some questions asking between and so there is one question that I have seen. I'm just posting in the Meet chat box.
there is a huge background noise. So the question is, going from the genomics to radiomics, does the number of features increase or reduce? So the features are if you compare in the genomic study, the features are 1 million. So it depends on the radiology. For in the radiology, you have a MRI scan. So in this case, if you are looking at number of features, or number of patient definitely increases in this case for radiomics compared to the genomic side. But it again depends on how do you look at it. If it is if it is yeah, okay. So if it is if it is very well disease, like radiology based kind of approaches, and you have a multiple longitudinal study, so then that means that you have a number of pixels or number of CT scans. So it again depends. It cannot be comparable in that in these areas. But in my opinion, maybe number of features are not as much as genomics. Genomics like SNPs data 1 million in a single shot. So I would guess for radiomics, maybe there will be less number of features compared to the genomics. The second question is, what could possible role in the omics in the future biotechnology domain? So in the omics, there is I would say there is a huge area, this omics area, and for the biotechnology domain, it is increasing. People are increasingly used for precision medicine. and personalized medicine. Or what does it mean? It means that you take a tablet, and then nowadays how things are working is if you have a disease and non-disease. But the whole idea of omics area is, can you identify which are the patients will be at risk? So can you so for risk population, you will be in a specific, you will be treating them differently, or the patients which are already in the suffering from disease. So I would say the omics will increase in future, and more and more technology is developing. Like people are doing now single cell RNA sequencing, people are doing more real-time based sequencing, so that will grow up. Then the second question is coming from the what is the difference between genomic and proteomics, and what the role of bioinformatics? So the genomics is talking about more kind of a gene expression type of analysis, so quantification of RNAs, whereas the proteomics quantification of the protein. So proteins are very close to the phenotype, okay, because protein are translated in terms of the phenotype. And role of bioinformatics are equally important in both the cases. So yeah, so these are the two different sort of data, two different sort of message in. Then the next question is, what are the scenarios in which a bioinformatic pipeline have to halt while execution? Bioinformatics pipeline has to halt. So I could not really understand the question. So I'm taking it when you are running and then you are halting. So at this moment, I mean, if there are heavy data sets, so many of the parameters, modeling, optimization have to run on the fly. So you cannot wait when this is giving. So parameter optimization and your execution has to go sometime all in one. So I could not get what does it all while execution it means in this case, because we do all on the fly. What is the scenario in which bioinformatics pipeline has? Okay, this is the same one. Do you have some application, social science application? Yeah, well, I mean, social for the social science applications, someone asked, yeah. So social science applications not as such. However, the policies, because we are working on the hospitals, the policymakers can take this knowledge. For example, you can take the COVID-19 situation. So if you identify some of the marker, and then the question would be, how do you legislation and how they are coming, I mean, how do you implement this? So this application is quite downline. I mean not immediately. So there are few areas where we are also working on the ethics of the data. So ethics of the data means not all the data you can take into account, because the data is coming from the patient. So question would be, if patient ethics are agreeing to sharing their data set. So if you are looking at the genome, which genome you're talking about? Did anybody authorized you that you use the genome? So this kind of ethics issue, and in HDR UK, there is a special thematic area where people are looking at only these things and give the feedback in other domain. So very interesting question. Yeah. So, okay, the next question, can we use omics technology for genetic disorder and pharmaceutical? Yes, definitely. And people are using it. And genetic disorders, you know, even the rare disorder, there are a few companies. Actually, I was working for a company in Cambridge called Helix. If you look at the Helix, they are just working on the rare diseases. They are using deep learning, convolutional neural net, and all this transfer learning, all these things, and trying to identify if there are any lead. And people are using in the pharmaceuticals like Novartis, AstraZeneca, you name one, Glaxo, they are using heavily. Is there any platform you or your team has developed to integrate different omics technology? Yes. So we have been working, not as such technology. So we have been working on the framework. So technology, we do Python, R, and all these scripting, but we made a framework, a kind of a tool where you can look at how the execution has been done. Next question is from Davesh Misra. Can metabolomics be identified as a reductionist approach toward the study of living system? How it's linked with other omics field? Yeah. So metabolomics, yes, definitely. So it is, metabolomics is a very important domain. compared to the still mainly in the metabolic driven diseases like type 2 diabetes, obesity, cardiometabolic diseases. Those are metabolic driven diseases, and there is a link between obesity, liver cancer, type 2 diabetes, and cardio. They're all linked. So the doing the metabolomics or high throughput data is quite valuable. Yeah. So people do LCMS, people do liquid chromatography, gas gas chromatography, or direct infusion, different technologies. The technology you will be taking based on what type of metabolite you want to capture. Are you wanted to capture volatile? Are you wanted to capture secondary metabolism? And this knowledge will come from the literature, also from the expert knowledge. And then you design your study, and then you generate the data, and then try to link for metabolic driven diseases. So yes, so they are, and how it is linked with other omics field. Now there are studies where people generated multiple different data set, multi-omics data set. So not only metabolomics, they might say, okay, I am interested in how inflammation is associated with metabolite. So then they generate inflammatory marker. They also generate metabolite. So you can see, so they, and finally, what they wanted to link the two different sort of data. So that's multimodality. So then you need some sort of framework, how best you can link with multi-omics data sets. Okay, the next question is from Sonia. How can we get, how can we do gut microbiome data analysis using omics? Okay, so there are two things. One, you are saying using omics. So the question is not very clear, because you are saying how do you do gut microbiome data analysis? The gut microbiome data itself is omics, one of the omics. Okay, now as I said, there are many different ways. So the gut microbiome analysis usually is two different steps. Number one step is upstream. Upstream means when you do a sequencing. So these are from the sequencing analysis. Gut microbiome sequencing can be done in two ways. One is metagenomics approach. Another is 16S sequencing. Now 16S is untargeted, so you don't know which microbiome is playing role. And another one is further downstream analysis. For metagenomics, you know which of the microbiota is involved. For example, Escherichia shigella. Shigella is heavily involved in diarrhea. Yeah. So, for example, we know it. So, if you wanted to know further, you will have to do metagenomics. Yeah. Now, what happens once you do the high throughput sequencing? You have to align your sequencing file, you have to do quality control, and this is one step. And there are very standard methodology, like PyCrust, KIME. People use QUIME, KIME, developed from the Harvard Medical School. They use initially this. And then the next step is you wanted to identify the differential expression of your gut microbiota. So differential expression, by the differential expression I mean is which microbiota is higher abundance in disease, which microbiota is lower abundance in disease. So so these are there are some standard tools for that, but sometimes what people do, people modify that based on their need, yeah, and then they go about it. If you like to know a little bit more, some link, you can contact me anytime. I will be happy to send you some of the link where you can look around and then see. Next question is from Nilesh Nishant. Can we do diagnosis by enlisting all the phenotypic traits? Yes, we can do the diagnosis by the phenotypic traits like ECG, EEG, but in my experience, I saw the clinical trait or phenotypic trait. These are adding value, but you cannot use for precision medicine type of approach. So if you wanted to, because genomic medicine and all these, you need to target some of the molecular trait. Now, the research has been shown combination of your phenotypic trait and your molecular trait given a huge impact in your disease state. Okay, so you can do phenotypic trait, but again, depends on what will be the phenotypic trait. Is it a scoring, or is it a movement? Is it a what sort of measurement you will be taking? But yes, it can be used for part of the diagnosis. Yes. Next question is from Vishaka, and techniques for plant breeding, which with the help of omics. Yes. So the plant breeding. So I did my PhD in plant breeding, by the way. So I mean, let me tell you that. And then I was working in Wageningen in Netherlands. This is one of the famous plant breeding, I mean, department after Cornell in United States and UC Davis. So the project, my PhD project, of smart breeding. So what we did, we generated F1 population. You know, in the plant it is easy. You can make a progenies. You can mate male, female, and then you can make F1, F2 eventually. So we actually, that's where my first interactions with the omics, and you can do all the techniques. You can do metabolomics, you can do transcriptomics, you can do methylation, and all these techniques. Now, if you are asking me which technique will be helpful, I will ask you which trait you are looking for. Are you looking for quality traits? Are you looking for quantitative traits? Okay, there are two different answers. Now, if you are looking for the qualitative traits, for example, if you go in the supermarket, you look for the tomato, and your tomato looks nice, red, because these are volatile. That's why you are looking, they look very nice. So these are metabolites. So maybe metabolite will help you. So you need a metabolomics. So it's heavily depend on which are the traits you are looking at. And probably you already know, because you asked me for the plant breeding, the quantitative trait like yield. People everywhere, I mean, you name one company like Monsanto, BASF, Bayer, whatever, they are behind the double-digit yield, and yield is a complex trait. So and then people dissect this complex trait in multiple different way, and then, for example, they can say, okay, I am looking at plant height. For plant height, I am doing transcriptomics, RNA sequencing, and then I'm also interested in heritable trait, because you wanted to know if one plant is giving more food, the next generation should give more food as well. So there are some genetics component and heritability associated with that. So it depends on the many of the questions rather than just doing simple one. Next question from N. Kumar. What are the open source or big data set organizations for digital image processing? Okay, digital. So you have to contact me because I cannot recollect in my mind, but there are definitely image processing tools where we can collect the data. Rosaline, how phase 2 gene app works according to AI? I don't know. I have never used, so I don't know. But I know phase 2 gene use a deep learning, because they have a enormous amount of data set behind. But I myself did not use it. So yeah, so I think this is the last question. Yeah. So, but okay, Shrikant, how can we use metabolism data set in omics and can be helpful? How can you use metabolism data set? So metabolism data set, again, I will ask you what type of metabolism you are talking about. Is it targeted or is it untargeted? It depends on which, and is it quantified? There are two types of ways you can fuse. You can use the different databases like KEGG database, Wikipathway. These are all qualitative, and you can say, okay, this metabolism is involved, but these are all qualitative. More kind of a relationship, interactions or not interactions, but again, depends on your research question, actually.
Okay. Okay.
Yeah.
I think the question is almost over. So there is one more professor in our group listening to us. Professor Valentania, are you here? Do you have any questions?
Yes, I'm here, and I just asked one and received the response related to social sciences. So the presentation was so impressive for me, with so many data, and I really appreciate it and congratulate Professor Animesh. Thank you very much.
Thank you very much. Thank you very much for your input, Professor Emily. Yeah.
Okay, Animesh, this was first. Let me say sorry for this interrupted service that we had because of all these unavoidable circumstances. Network is highly loaded now. You know, we are all operating through a network, and somehow there was some interruption. So sorry for that. And I also say sorry to my participants who are live on YouTube. Basically, we are broadcasting live on YouTube because the participants are huge, around 1,000, which we cannot manage in Google Meet. So sorry to all my participants, but I believe the type of response that we have received in YouTube, it was a fantastic lecture, I would say, Animesh. It was really a very good feedback that we have received from our participants. So thank you very much, Animesh, for sparing your time and giving an insight into big data driven diagnosis in such a lucid manner, such that a layman should clear some of his doubts that how to go about and how the thing works. So it was a fantastic session. I have gone through your entire session, and I think today I could understand the length and breadth of the work, but not if exactly the core of the work, but at least what is the length and what is the breadth, and what all can be added into this set. What more elements can be added into the set of omic analysis? That was a bit clear to me. So it was altogether a very nice lecture, I will say. And thank you once again from the organizer side, as well as on behalf of NIT Silchar. Big thanks to you, so that we got associated officially with our institute, and I'm looking forward that to seek more collaboration from your university and from your company, that if we can have some sort of academic exchange and collaborations, research exchange and collaboration. I will initiate discussion with my higher authorities, and we'll see what can we do in near future, and work together in this direction. So thank you once again, Animesh, for this beautiful lecture, enlightening lecture. Thank you once again.
Thank you very much for inviting. Thank you very much all the participants as well, and then NIT Silchar who are all involved to making this happen. Thank you very much.
Thank you.
Thank you, sir.
Bye.
So bye-bye, Animesh. So my dear participants, we are signing off now for today, and I am again saying sorry to all of you for this interrupted service. Some of you may not have got the link in a proper time and may not have attended a very small section that was left over. And anyway, nonetheless, I think we could somehow resume after a small glitch. But let me tell that for today's session, if someone you could not submit your feedback, please write to us what was the reason exactly. You have our mail ID, and we'll go through your mail and see that we can consider your. But we can see a lot of responses have come. The feedbacks have already arrived, and if one or two people could not give the feedback, please write to us. We'll see what can we do at a later stage. But thank you once again for attending this session. So tomorrow our session starts at 10 a.m. in the morning. So hope to see you again tomorrow morning. So signing off for now. So stay safe, stay healthy. Bye-bye.